solve. That's also our way of finding our x-intercepts if we were to graph. So in this first little exploration, we're going to solve x squared plus 4x plus 2 equals 0 by a technique called completing the square. So the first thing we have to do if we're going to use this method, I'm going to go ahead and start with my equation in standard form. So we have x squared plus 4x plus 2 equals 0. That's one we're wanting to solve. That's right up here. And we need to start by moving our constant, or our c value, to the other side of the equation. So I'm just going to go ahead and subtract 2 from both sides. Now if we look over at the algebra tiles, that is the equation that's being modeled. We have x squared, then we have 1, 2, 3, 4 x's over on the left side, and then we have a negative 2 over on the right. So that's being modeled by our algebra tiles over on the right-hand side. Part B says 4 algebra tiles are added to the left side to complete the square. So notice now how on the left side, we now have the shape of a square instead of having the empty space like we did up above. So if 4 algebra tiles are added to the left side to complete the square, why are 4 algebra tiles also added to the right side? Well, remember, when we're solving equations, we have to make sure that we keep the equation balanced. So whatever we do to one side, we have to do the other. So why are they added to the right side? We have to keep the equation balanced. So whatever I do to one side, I'm going to do to the other side. We're going to keep our equation balanced. So as I continue down, it says use algebra tiles to label the dimensions of the square on the left and simplify on the right side. So on the left, a lot of us used to use the boxes when we would factor or multiply. So if we go ahead and write the side lengths, to get x squared, we would have an x and an x. And then we would have, on this place, we would have a plus 2. X times 2 would give us 2 x's there. And then this side would also be a plus 2. So again, it's similar to when we used our boxes to either factor or distribute. X times x will give us x squared. X times 2 will give us 2 x's. 2 times x will give us 2 x's. And then 2 times 2 will give us 4. Now over on the right side, we have 2 negatives plus 4 positives. So we end up with 2. So if we go to write the equation modeled by the algebra tiles, notice we have multiplication up in the top left. So we have x plus 2 times x plus 2, and that's going to equal positive 2. Now this side, since it's the same thing twice, we can write that as x plus 2 squared equals 2. So now notice on that left side we have a square. We have x plus 2 quantity squared. That's why this process is called completing the square. Once you get used to it, this process, a lot of you will find it quicker than our factoring and even our quadratic formula at times. Now we're going to use our knowledge from last unit and solve using square roots. On the left side, we have x plus 2 quantity squared. We have the squared term all by itself. So to undo the square, we find the square root. Now on that left-hand side, all that does is it removes the square. The square root undoes the square. So on that left side, we just have x plus 2. Now over on the right hand side, our work with square roots, we've just been rounding those to the nearest hundredth, and that's what we're going to continue to do here. So the square root of 2 is going to roughly be, oops, I need to do an approximate symbol, squiggly equals 1.41, but then also remember the square root of 2 could also be negative 1.41. That's from our work last unit, solving with square roots. Now to finish this off, we just subtract 2 from both sides. So we have 1.41 minus 2. So 1x is roughly negative 0.59. And then the other one is approximately negative 3.41. If we were to graph this, these would be our x-intercepts. If we were to sketch a graph, these would be our x-intercepts. Now, something else cool I want to show you from this piece. To start the question, to start this problem, we moved our c value, our constant, over to the right side. If I bring this constant, I know it has changed from the work we've done, but if I bring that constant back over to the left and kind of reset where we were with the equals 0, now what we have is our vertex form from last unit. So now we can very easily find the vertex and axis of symmetry. Remember, plus 2 inside the parentheses, we go left 2. The minus 2 outside would cause us to go down 2. So our vertex would go left 2, so negative 2, and it would also go down 2, so another negative 2. This would be our vertex. Then the axis of symmetry, remember, is just the x value at the vertex. I know a little tougher to see because x and y are the same on this vertex, but the same nonetheless. So with this process of completing the square, we are going to do more with this. With this process, we're able to solve using square roots, which most of us from last unit are very good at. And we're also, for some of us, it's going to be a little bit easier to find that vertex and axis of symmetry piece. So let's try another one. So we can make this visual. We're seeing that we are creating that square. Let's try another one visually with the algebra tiles, and then let's use that work to figure out the step-by-step process for this without having to do the tiles every time. So we're starting with our x squared. Ooh, whoa, here we go. We're starting with x squared plus 6x plus 5 equals 0. So what I want to do to start this process is I want to move our c value, or our constant, over to the other side. So we have x squared plus 6x on the right, and we can see that in our algebra tiles. And then over on the left, we have a negative 5. Part B says use algebra tiles to complete the square. So we need to fill in with some of those ones. So let's see how many that's going to take so we can make the square. I know I should have said this earlier, but at any time when watching this, if you need to pause to catch up or rewind to rehear something or re-see something, please take the time to do that. All right, so over on that left side, it looks like we're going to need 9 little 1 tiles to make that perfect square over on the left side. Just like we did earlier, though, we need to keep our equation balanced. So that means we also have to put, I'm going to go ahead and put them off to the side here. We also have to put 9 positive tiles over on the right side because we need to keep things balanced. So now that we have the square, again, we use this process when we are factoring and distributing. To get the x squared, we would need an x times x. And then to get 3x, we would need a 3 up here. Same would be down here. And then 3 times 3 would give us the 9 that we need. These are both positive. Then over on the right side, we have 5 negatives and we have 9 positives. So that side's going to equal 4. So what we end up with is we have x plus 3 times x plus 3 on the right, or excuse me, on the left side equals 4 over on the right side. I'm going to rewrite the left side so it's a square. So now I can very easily solve using square roots. So x plus 3 could be positive 2, or x plus 3 could be negative 2. Subtract our 3's. And once again, we would have x-intercepts at -1, 0 and -5, 0 if we were to graph this. Same as we saw earlier, if we needed to graph this, we really don't have to do a lot of extra work to find the vertex and the axis of symmetry. So if we just undo moving our constant, let's bring it back to the left. Now I have vertex form. The plus 3, we're going to go left 3. The minus 4, we're going to go down 4. So left 3 would be -3, down 4 would be -4. Axis of symmetry will be x equals, and then the same x value as what we have on the vertex. I know for some of you, you're looking at this process and thinking, oh my gosh, I'm going to have to draw this out every time. Nope, we're going to come up with a pretty slick way to complete this square, solving with square roots, something we're already familiar with, as is vertex form. So this is just another way we could use to solve an equation or to get the pieces of our graph. So if we look at the two equations that we solved, I'm just going to go ahead and bring those down. Grab my first one here. So x squared plus 4x plus 2. And what we ended up with, we had x plus 2 squared Oh, let me back up. Hang on, I forgot we had subtracted our 2. We subtracted our 2 over our constant, our c. Then what we ended up with was an x plus 2 squared, and we equaled positive 2 over on that side because we ended up adding 4 to both sides. So let me go ahead and show. I know we did it with the tiles, but let me go ahead and actually show it with the numerical values that we did add 4 to both sides to get the square that we needed with our algebra tiles. So then this side became x plus 2 squared, and this side simplified to 2. The second one that we had x squared plus 6x plus 5 equals 0. we moved our c, our constant value, to the other side. Then what we found to make our square is we had to add 9 tiles to both sides. We ended up our square, our sides were x plus 3, and then we ended up with a 4 on that other side. So looking at these two processes without the algebra tiles, let's take a look at the step by step for each one of these and how we can quickly get our square without having to use the algebra tiles. So the first thing that we did in each one was we moved the constant, or our c value, to the other side. Sometimes in this case we subtracted both times, sometimes you might have to add. So we move the constant, our c, to the other side. Then we had to find the piece that would make our square. If you notice in each one, all we ended up doing each time, we had our b value of 4. The number that ended up to complete our square was if we took half of that value and we squared it. So if we take half of 4 and square it, we got positive 4. We took half of 6, which is 3. You square it, you get positive 9. So find half times b. So half times your b, so half of b. Actually, let's just make this all one step. Find half of b and square it. Add the square to both sides. Write the trinomial as a binomial squared. Now you might be thinking like, oh wait, Miss Golly, I really understood it. I really saw it with the tiles. How does that process work? Let me see one walking through that process. So that's what we're going to finish up with today. So I'm going to do those 4 steps with a couple examples, and then you have some time to practice. All right, so in letter A, step 1, move the constant, which is our c value, to the other side. So in this case, I have -1 is my constant, so I'm going to add that to the other side. So x squared minus 2x will equal 1. That is step 1, done. Step 2 says find half of our b value and square it. My b value in this case is -2. So I'm going to take half times -2. That equals -1. I'm going to take -1, put it in parentheses, and square it. I get 1. Step 2, done. Step 3 says to add that square to both sides. So we're going to add 1 to the left side, and we're going to add 1 to the right side. Then step 4 says write the trinomial as a binomial squared. We're always going to have an x. And then the number that goes inside the parentheses is the same value we got when we found half of our b. And then on the other side, we have a plus 2. So really, this process is pretty quick. We move our constant to the other side. We multiply our b value by a half, or divide it by 2 if you'd rather look at it that way. Take that result and square it. Add it to both sides. Write our binomial squared. Then from here, undo the square by using the square root. X minus 1 could equal the square root of 2. We saw that earlier. It was approximately 1.41 or negative 1.41. Add 1. X is approximately 2.41. And then x is approximately negative 0.41. If we were to graph this, again, those would be our x-intercepts. And then if we wanted to graph, we could rewrite this in vertex form by just moving that 2 very easily over to the other side. Minus 1 would go to the right one. Minus 2 would go down 2. Right 1, down 2. Axis of symmetry is the x value at the vertex. I do just want to go ahead and show you one more example with this, just so we can repeat that process one more time together. Step 1, move our c, our constant, to the other side, so the number without a variable. I'm going to scoot this over just a little bit. So that's our step 1. Pause as you need to catch up at any point, rewind, whatever you need. That is step 1. Step 2 says find half of b and square it. So my b value is 3. So I'm going to find half of b, or b divided by 2. And this comes out to be 1.5. I take that value and I square it. So 1.5 squared is 2.25. That's the value I need to complete my square. So that is step 2. We find half of b and then we square it. Step 3 says we're going to add that square to both sides. So I have x squared plus 3 on the left side. I'm going to add 2.25. Then on the other side, I have negative 1 plus 2.25. We have to keep the equation balanced. Step 4 says write the trinomial as a binomial squared. We're always going to have our x in there. And then again, half of our b value goes in the parentheses. And then over on the right, we're going to simplify here and get 1.25. Your square is complete at this point. Now from here, we just need to solve. To undo the square, we do square root. So x plus 1.5 is approximately the square root of 1.25 is roughly 1.12, or x plus 1.5 is approximately negative 1.12. subtract 1.5. X is roughly, let's see, 1.12 minus 1.5, negative 0.38. And then squeezing it in on the bottom there, negative 1.12 minus 1.5, negative 2.62. Again, those would be your x-intercepts. If you wanted to find your vertex, if you had to graph, you wanted to find that vertex pretty quickly. Take our square, move our constant back over. We'd have x plus 1.5 squared minus 1.25 equals 0. Adding 1.5 inside the parentheses is going to cause us to go left 1.5. And then minus 1.25 is going to cause us to go down 1.25. Axis of symmetry, same value that x is at your vertex. So the step-by-step process, if you didn't get a chance to jot that down, please do so. You can always rewind that part. You can also rewind any of these examples I went through as well. But that is your general process. Once you get the hang of it, it does start to go really, really quickly. But to get the hang of it, it does take practice. So now the time is yours to try out that practice.